Dalton's law of partial pressure. In this lesson, we are going to learn partial pressure, Dalton's law, and proof of Dalton's law. These are the points we are going to learn today. So let's get started. The first point is partial pressure. Partial pressure. What is partial pressure? Let us consider this is a container in which there is a mixture of some gases: oxygen gas, hydrogen gas, nitrogen gas, etc. A vessel in which a mixture of some gases. What is partial pressure? The pressure exerted by one of the gas mixture is known as partial pressure. The pressure exerted by oxygen gas is partial pressure of oxygen gas. Similarly, the pressure exerted by nitrogen gas is known as partial pressure of nitrogen gas. In this mixture, the pressure exerted by hydrogen gas is known as partial pressure of hydrogen gas. In a mixture, the pressure exerted by one of the component gases is known as partial pressure, and it is equal when it occupies the whole volume alone. This is partial pressure. Now, Dalton's law of partial pressure. Let us suppose this is a container of a mixture of some gases. Suppose gas 1, gas 2, and gas 3. Gas 1 in 1 moles, and its partial pressure is suppose P1. Then for gas 2, it is suppose in 2 moles, and its partial pressure is P2. And for gas 3, in 3 moles, and its partial pressure is P3. Total pressure is suppose P, total moles N, and total volume V at Kelvin temperature T. Dalton's law is total pressure is equal to sum of partial pressures of the component gases. Dalton's law is total pressure in a gas mixture is equal to the sum of the partial pressures. This is Dalton's law. Now, let us prove Dalton's law. Proof of Dalton's law. We know ideal gas equation PV is equal to N T. Then P is equal to N by V RT. Suppose this is equation number 1. P is equal to N by V RT. For the first gas, we can write according to ideal gas equation, P1 is equal to N1 by V RT. This is equation number 2. This is for gas 1. For gas 2, we can write P2 is equal to N2 by V RT. This is equation number 3. For gas 3, this can be written P3 is equal to N3 by V RT. This is equation number 4. P3 is equal to N3 by V RT according to ideal gas equation. PV is equal to nRT. Now, adding these equations, equation 2, equation 3, and equation 4, we can write P1, P2, P3. P1, P2, P3 is equal to RT by V, N1 plus N2 plus N3. Here, RT by V is common. Then, RT by V, N, total number of moles. Total number of moles. This can be written N by V RT. Suppose this is equation number 5. Now, from equation 1 and 5, we can write one and 5. P1, P2, P3 is equal to N by V RT. Here, N by V RT is equal to P. That is, P is equal to P1, P2, P3. Dalton's law of partial pressure. Total pressure is equal to sum of the partial pressures of the component gases. Thank you for watching.